Surprise, I'm back. Even though I'm not in the room with you after my 3 weeks there, I didn't want to leave you stranded high and dry until we know that there's somebody in the room in between me and when Mr. Childress comes back that knows the goods. So I'm going to prepare some topic videos so that you can still keep marching along and have stuff to do, because the worst thing is to just have nothing. Keeping your brain occupied is a good way to make the time go faster. So after all the fun we had the last 3 weeks, the next topic in line for you was to visit polynomials in general. You've seen polynomials already. This may be a little bit of a review, but that never hurts. Okay, so I'm going to walk you through some of the ideas. I'll show you a few sample problems, and then as normal, there is a worksheet in Google Classroom where you can do lots of practice. So what we're doing here isn't necessarily anything new. It's just possibly made a little bit more general than what we talked about or what you had heard about in the past. So for example, y equals 3x minus 1. There you go. That is a polynomial. You've already dealt with polynomials. So is this 5x squared plus x minus 3. That is a polynomial. Now, when you're working on algebra to start with, linear equations, quadratic equations, that's kind of where you live your life, but those are just two specific examples of a broader category of thing. So let's talk about that broader category. It's expressions like these which involve integer powers of x, positive integer powers of x, none of that 1 over x nonsense. Maybe there's constant multiples on the powers of x, and then these terms are added and subtracted, and that is a polynomial. You can go read a much more technical definition of what it is, but they're kind of easy to identify. Okay, so every building block of a polynomial, every piece, the little bits that are added or subtracted are called terms. So in this 5x squared plus x minus 3, there are 3 terms, and they are the 5x squared, the x, and the negative 3. So term 1, term 2, and term 3. We will have to be careful about watching minus signs. This negative sign with the 3 makes that term negative 3. Polynomials don't have to have a subtraction. The operations of plus minus can be whatever they need to be. Okay, so here's some terminology that goes with this. When you look into one of these and find the term that gives you the highest power of x that you'll find, that exponent, that power of x, is called the degree of the polynomial. So in this one, the winning term is the 5x squared, and so that means that the degree of this polynomial is 2, because that is the highest power of x that we see. The asterisks I'm saving for later, just as a reminder. This one's already ordered nicely, but if your polynomial is a little disordered, there's nothing wrong with rearranging the terms, as long as you're careful about those negatives, so that you have them in like the highest power first and then decreasing from there. And remember, this negative 3, technically there's a ghost x to the 0 attached, but anything to the 0 is just 1, right? So we don't need to see the x to the 0, but if we need to pretend it's there for whatever reason, that's fine. The term that you've identified, you go, aha, now I know the degree because I found the highest power of x. Usually it's first. If it's not, you might be inclined to rearrange things. We'll practice that in a minute. But this is called the leading term. A, because it does have the highest power of x, so it's leading in a strength kind of idea. But when we have these organized nicely, it's always the first one. So it kind of leads the way. And then the asterisks are here just to remind us that the example is given as with the variable x. We're talking about powers of x, but the variable doesn't have to be x. The variable could be t or s or q or b or a frog. Whatever you want to put there as your variable, it's cool. Okay. So here's a polynomial that's fairly disorganized. This should bug you already. Okay, so first of all, we can say there's 1, 2, 3, 4 terms altogether. looking through the terms to spot the term that shows us the highest power of x. Currently it's the second one. The power of x is 5, so this polynomial is degree 5, but it is disorganized, so we're going to move things around. And to do that, you learned a long time ago magic words like commutative, right? When you're adding two things together, you can reverse the order of addition. 3 plus 5 and 5 plus 3 are the same thing, right? That's the case with this. We just have to be a little more careful in applying it. For example, this negative sign right before the 3x squared, we don't leave the minus sign in place and move the 3x squared. That negative sign is part of a constant -3 that's the multiple. So the minus signs are going to get carried along with the terms as we move them around. But ideally, I would like the leading term, the 2x to the 5th, to go first and then descend from there. So I would like, really, I just need to move this negative x with the negative sign, pick it up, move it over, plop it down right before the 3, and now this looks more pleasing because the powers of x are in order in a decreasing fashion. That's normally how we like to see our polynomials. All right, so just with that little bit of business, counting terms, identifying degrees, identifying leading terms, on that practice sheet that is in Google Classroom for this topic, the first handful, there's just, I think, like 4 of them, are questions where you're posed a polynomial and told to identify all these things. So this might be a good time to just pause this and go have a look at that practice sheet and make sure you're cool with just that introductory business. Okay, either we didn't go anywhere or we're back. So now we're going to learn how to take two polynomials and add them together or subtract them. Sounds like fun. It's bookkeeping. That's all it is. You just have to watch the details, just like with anything else. As we're taking, this polynomial and that polynomial and adding them together, that means we're going to look for terms that have the same power of x and try to combine them. We can't mix and match different powers of x. They stay separated. But when we have a long string of addition or subtraction and we find x to the third here and a term with x to the third down here, we can take those terms and add them or subtract them together to shrink things down a little bit. Okay, again, with the reminder about negative signs, be very careful. So if I have this polynomial minus this polynomial, that minus is acting on every single term inside that polynomial being subtracted. So you have to be careful with tracking down those minus signs and using them properly. Otherwise, it's bookkeeping. Okay, so here are some examples of how this works. I've got 4. I'm going to flip over to my little tablet, sort of to role model. If you were taking notes on this, you might want to follow along as such. So I am going to go over to my tablet, and I realized I'm on the last page first, so I got to back myself up. Okay, so we're going to take a look at this first one. You think I would pause the video and fix it, but I'm not. I'm just gonna do this live right here. I'm gonna reconnect. There we go. Bingo. Okay, so this was the first one on that page. It was nicely typed on the page. I'm writing on a tablet with one of these digital pens, and I just can't do that very neatly. But hopefully this is semi-legible. So we're adding the first polynomial, which has 3 terms. This first polynomial has a degree of 2, and x squared is the leading term. Then we're going to add it to this next one, which has 4 terms. It has degree 3. Okay, so a prediction, first of all, is by the time we're done sorting it out, the degree of the result is going to have to be 3, right? How many terms are in the new one? Well, that's going to depend how many of these terms we get to add together. So the x cubed is going to end up by itself. There are no other x cubes it can combine with, but there is an x squared in this first one and a 2x squared in this second one. So this is just a matter of fishing for terms that have common powers of x. And I'm going to go through and pick out the terms in decreasing order of the exponent so that I can write the polynomial in a nice organized fashion. So you can just imagine this whole string of 1, 2, 3, 4, 5, 6, 7 terms. Just imagine the parentheses gone, right? So we fish out the x cubed. That's happy by itself. And then we're going to go grab our x squareds. So there's one from the first polynomial, and there's one from the second polynomial. So altogether, there's 1x squared from the first, 2x squared from the second. Ta-da, there are 3x squareds altogether in this sum of the two polynomials. Let's go look for x to the first. Well, there's one right there. There's one right there. And if you look carefully, so this 2x plus this negative 2x. What just happened? Well, the 2x's canceled out, so we don't even have to write them. We could write a plus 0, but why clutter things up? And now we've used everything except the constants. So there's a 1 up there, we're adding this 5, and there's a 6. So there's the result. Degree of 3. It turns out we only ended up with 3 terms because the x to the first terms, they're gone. They canceled each other out. Right? And it's going to be that story for the rest of these as well. Okay, so the second one. Here we go. We got a polynomial with 3 terms minus another polynomial with 3 terms. So this is going to be practice managing the minus signs, managing the negatives. So back to my tablet on the next page. Let me go ahead and write all the terms out that are involved in this mess, but in a way that I'm going to remove the parentheses and let this minus sign act on everything in there. Remember, when this minus sign is sitting here, we are subtracting everything in this second polynomial. So we are subtracting that first x squared. We are subtracting the minus 2x squared. And then finally, we've got a minus negative 2x, which becomes a plus 2x. So I wanted to do this by itself to make sure we're managing the minus signs. As we get better, you can do a lot of this just visually with your brain power, but I wanted to see everything explicitly. So now let's go and collect. The highest power of x, well, there's the x cubed. So the new result will be x cubed. There's nothing else to add to that. Now we're going to fish out our x squareds. Oh, look at that. I didn't even catch that the first time through. I probably should have added these two things together and made them 3x squared to begin with, but I didn't do it, so let's just carry on. We are going to gather the x squareds. There are 3 of them. There's a negative x squared minus another x squared minus 2 more x squared. So altogether, minus 1, minus 2, minus 4 x squareds. And those are taken care of. So I'm actually going to go ahead. I'm going to just kind of knock away the ones that we've already dealt with. And then finally, the only things that are left are the 2x and the 4. We got a plus 2x, a plus 4. And I will write them in that order, not in the order they appear in the previous line, to make sure that our polynomial is descending, right? The powers of x are getting smaller. And there we go. There is the net result of those. I'm going to guess if I went back to the book or the PowerPoint slides that this came from originally, that I peeled them out of for practice, this term might have been x cubed. And I just copied it wrong, but we just, we did it the way it appears on this page, and that's fine. It is correct for what it was. All right, there's the next one. If you don't believe me, here it is. 2t squared plus 6t minus 9 plus t minus 7. This one is more practice with not freaking out because we changed the variable from x to t. Nothing changes. The process is still the same. So hunt for the largest exponent on t. That's coming from that first term. That is not going to add to anything else, so we'll just leave it as part of the result, and we like it first because it's the leading term. This result will have degree of 2. Now we're going to fish for our t to the firsts. Well, there's one, there's one. Altogether, that looks like a plus 7t. And then our constants, right? There's our minus 9 and our minus 7. And let's be careful, it's negative 9 plus negative 7. In other words, negative 9 minus 7, so that becomes negative 16. And this one's done already. And last one. Okay, I changed the variable to s. This is good practice to keep your s's visually distinct from your 5s, because that will cause a mess if you start losing track of what's an s and what is a 5. That's bad news. Okay, what's going to happen here? Oh, look at this. This time there's 2 instances of our highest power of x. That's exciting. So I see s cubed right there and right there. And there's a subtraction. So does that mean they subtract out and cancel and go away? No, because we got the double whammy minus sign right there. So it's s cubed, this first minus, and then a minus s cubed. So it's s cubed minus a negative s cubed, or s cubed plus s cubed. So altogether 2s cubed. We could write this term out again, having distributed the minus sign through. I did that a couple of examples ago, but let's just eyeball things here. Now let's track down the s squareds. There's one right there. There's one right there, and remember there's a subtraction in between, so negative s squared minus a positive 5s squared. So negative s squared minus 5s squared altogether, that'll be negative 6s squared. And then finally, this is an s, right? It's not a 5, it is an s. Here, I'll prove it. I better not be wrong. Nope, that is an s. So a single s. Are there other single s's? Nope, there are not. So that's the only one. Let's just put it in the result. And then now our constant term, well, it's this minus 5 is it. But remember this negative sign here. So we've got a minus negative 5 altogether plus 5. So the net result of the subtraction of these 2 polynomials is a new polynomial with 4 terms, degree 3. And the 2s cubed is the leading term. And in terms of an introduction, that's all we got. Identifying the characteristics of a polynomial, the degree, and the leading term, and then adding and subtracting a couple of them together. Get warmed up with that, because the next thing we're going to do, not today, but I'll put up another video for tomorrow probably, is going to be multiplying polynomials. And that's fun. All right, good luck with this. Hop on that worksheet, practice it, enjoy the relative simplicity of these problems. And stop.